Welcome to episode 3 of Ask the Grounding Experts, where our experts from ENS Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, our very own David Stockin takes us behind the curtain and answers the shocking, well, hopefully not shocking question, do lightning protection systems actually work?
Yeah, so do lightning protection systems work? That's a great question. So a couple of details. One thing we should talk about is what is lightning? Well, lightning is a bunch of electricity coming down from the sky down to the earth. Sometimes it comes up, but for this purpose, let's talk about the ones that come down. And it's a lot of electricity. Hundreds of thousands of amps in some cases can come down. And they tend to strike buildings, and this becomes a problem. If your building happens to be wood, well, the lightning likes wood. It will travel right through the wood quite happily. The problem with wood is when it gets hot, it tends to burst into flames, and this is bad for our buildings, right? If your building happens to be made out of steel, right? The steel, which is conductive, certainly, but the problem is it's also highly magnetic. So that it has to form these magnetic fields. It have to take time to form, and then time to collapse, and that increases the amount of time that electrical energy is inside of our structure. And when we have a lot of electronics that have copper in it, then the magnetic fields prefer that copper, and it causes damage to our electronic systems. So steel turns out not such a great system, particularly if you have a lot of high-tech electronics inside of them. Steel tends to not be ideal, although it definitely can handle and tends not to burst into flames when struck by lightning. If your building has to be made out of stone, well, stone happens to have a lot of water in it. When concrete or stone gets too hot, the water that's inherent inside of that turns into steam. 1 cup of water will roughly turn it into about 1,700 cups of steam quickly, and it causes the concrete and stone structures to explode. This is also bad, right? And just consider what happens when you take a blowtorch to concrete. It'll start popping and exploding, right? That's the water inside of that concrete turning into steam and causing shards of concrete to come flying off violently, right? So you definitely want to provide some protection. And one of the best ways to protect your structures from lightning is to provide it a nice preferential path. What does electricity like to travel on better than anything else? Well, copper. So copper is somewhere between 12 to 17 times more conductive than steel is in a pure DC level, right? So literally it really prefers it. So if you have a piece of copper compared to a piece of steel of the same diameter, you'll get 12 to 17 times more current flowing down the copper than the steel, right? But it's also anywhere between 250 to 6,000 times less magnetic than the steel is. In fact, it's diamagnetic copper. So copper helps to collapse magnetic fields. So the steel has to form the fields and collapse the fields where it takes time for that to happen, where the copper tends to want to just collapse it and reduces that resonant frequency that will bounce around inside of our steel structure. So copper's a great choice. So we basically place a net over the top of our building so that the lightning, when it comes down, it will prefer to travel on the copper component versus any other component inside of our building down to earth. Again, electricity is electrons that are freed from the orbit of their atoms, right? And where do we happen to have a lot of atoms? The earth. Those electrons want to get back onto an orbit around an atom somewhere. We've got tons of them in the earth, so lightning, it comes down, it goes into the earth and gets dissipated across into the earth because those electrons are happy. They get back to an orbit around them. So that's the general principle, is instead of allowing that that electricity to travel through our combustible buildings, we provide a copper path for them to travel down to Earth instead. Now, do they work? Actually, they very well do. All the way back from Benjamin Franklin, who put the very first lightning protection system up on the Parliament building in England, we have been able to demonstrate since then that they are highly effective. In fact, the studies show that that buildings struck by lightning, compared to those that have lightning protection on them compared to those buildings that do not, suffer only about 1% of the damage. That's how efficient they are. Right. So on average, a building, the last studies I saw, were about $400,000 worth of damage to the average building that's struck by lightning, where one that has lightning protection on it only suffers $4,000 in damage. So with a good lightning protection system, you actually get about a 99% efficient system for protecting your structure from lightning. The fire groups, fire associations have recommended to insurance agencies to provide 29% insurance discounts to those folks that actually have lightning protection systems on their structures. Now, whether they're giving that to you or not, I don't know. But you certainly are definitely protected. There's other advantages to having this lightning protection system on top of your structure beyond just lightning protection. It's a great Faraday cage and helps to balance these differences in potential. And this will certainly have another video about differences in potential, why it's important. But when you have a Faraday cage outside your structure, it eliminates the difference in potential across that structure very, very efficiently. And items such as Cat5 cables and computer systems no longer become a preferable path for objectionable currents, transients, harmonics to travel on. Instead, they travel on your lightning protection system. So despite, even when the sun is shining and the birds are chirping and there's no lightning anywhere, a good lightning protection system is actually providing you with an excellent system of infrastructural system for protecting your electronics, even in those conditions. So there's lots of good reasons to have a good lightning protection system. Of course, that lightning protection system is only as good as its grounding system that's tied to it. So make sure you check both. These are coordinated systems that must be tied together, and they must be tied together in a very specific manner. We don't want your lightning protection systems to cause damage to your electronic systems, but we do want to make sure they're at the exact same potential as your other sensitive electronic systems. And tying that in definitely needs to be handled in a proper way. You want to use someone with some expertise who understands these differences to make sure that your buildings and the sensitive systems inside of them are protected properly. So, do lightning protection systems work? Absolutely. There is centuries of data to back this up. It is one of the most documented phenomena in all of electrical systems, and it's been proven to be one of the most efficient and effective systems. Good lightning protection systems definitely do work. Thank you.
Thanks so much for listening. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you want to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. We'll see you next time.